Morning, everybody. I don't know if I really need this for this little tiny room.
Small room. Are you recording?
I think so, yes. So, quick question for everybody. And please you won't offend me. You won't offend me at all. How many people may have to leave early today, sometime throughout the day? Early as in within 2 hours? You have 2 hours with us? How many people have to leave at lunchtime or by lunch?
I'll be back.
Okay. And then the rest of you guys who raise your hands, like you'd like to be done by 2, 3? You'd like to be done by 3? 3. If we were done by 3, that'd be awesome. We have a whole bunch of modules that don't necessarily have to be covered because some things were gone over yesterday. So Roger did, a fantastic job doing the flare gas recovery compressor review and discussion in the big room. But I don't know how many of you were in the big room because you probably wanted to go off and hear other things. So there is some really important reasons that Roger put that together, making some numbers available to the public for the first time ever, which are hugely helpful for the refineries needing to do their flare management plans. So from a costing point of view, how much does it cost to do certain things? So it's very helpful information, and we want to make sure that you know what everybody else is talking about. So that's important. There's a few other things that maybe aren't so important that are interesting, but all the information's in the booklet anyway. You can always go back and read it, like the QA, QC, SEMS manual that you have to write as part of your plan. It's nothing that gets mailed in to the agency, but it's something that you got to have. A lot of detail in that section. Maybe you do or don't need to go over that in detail as a group. So we will kind of do the Super Gumby thing again and kind of bounce around. We also have a couple of honored guest speakers today that we definitely want to squeeze in, and those include so Roger, of course, from John Zink. Chris Ng is going to be showing up, but I don't know when. I haven't seen him yet this morning. Maybe while Herman's doing the talk here, I may have to step out on the phone and try to track down Chris and see where he is. And
What is that?
that is Zico yesterday made mention of a site in Nigeria that is an open ground flare with no fence. So, yeah, not a very pretty field, is it? Here comes Andy. Hey, we could do Andy first.
I don't care. Let's see if he's ready.
If he's ready. Yeah, I don't know. Good morning, sir. We're all amongst friends here. We're just talking casually. Would you like to go first? No, you're gonna let. So I think we're gonna do two discussions on the 114, how to respond to a 114. What does that look like? And then how to do the consent decree, quick overview. A lot of you have seen these and read these 1,000 times, but we'll touch on some highlights and let you see some of that. Let's do the consent decree stuff first, and then we'll circle back on the gas management and the safety issues, which I think are really important. So I appreciate everyone's flexibility, of course. So that's kind of the idea. We were just talking, Andy, about how some people would like to try to be done by 3 o'clock because we're all burnt out. Ha, no pun intended. So being a little burnt out on flares, let's not spend too much time on this. And some of these things are really interesting, but may not have any applicability to you at all. Things that Troy finds really fascinating. BLM changes and the international stuff, which is really kind of cool. And maybe the air dispersion modeling thing that we've been doing quite a bit of. So interesting, but not critical that we touch, I don't think. All right, so we're going to turn this over to Herman, and he can be the warm-up.
Yes.
Hope you all had fun last night. I have no idea.
Okay, the point I made yesterday was that these combustion zone parameters assume everything's well met. So in that case,
Yeah, that's the magical world of Google Images. We do a good job of citing where we try to go back to find the original source of our pictures, but we have no idea what any conditions were around those pictures. All right, so I'm going to go through the 114 response. Sage has been involved in a lot of these, so we've kind of seen some similarities, some differences, and just kind of this is kind of more of I was hoping to spur some just discussion amongst the group if somebody's had a different experience, yeah, and. So it's I'm going to just kind of more talk from our experience with them and some of the things that we see that the EPA is definitely going to be asking you about. So with the section 114, I'm sure everybody's aware. That comes from the section 114 of the Clean Air Act. It gives the EPA the powers to request information from facilities, and you are obligated to provide that information. It can be done for a number of reasons. I mean, everybody hears about the information collection request, the ICRs. There was one done on the refinery sector back in 2011, and now there was just one that's been done for the ethylene industry. So I mean, we saw that all that data from like the refinery ICR pretty much was used to develop the changes to the proposed MAC-CC. So we're assuming it's all going to go the same, and that the ethylene ICR is going to be used to develop changes to the ethylene MAC. So there is a reason why they can do that. But we also, and people kind of understand that one. They got to keep up with technology. They need to know what people are doing. The one that gets kind of a little more personal is when you've already been part of the either the sector-wide information collection request, and then you get a letter in the mail for your specific facility asking for a lot of specific data. Generally, the sites tend to think that the amount of information they request is a lot. We agree with that. The number of questions that you're asked varies from site to site and region to region. It seems like a lot of the ones we've seen a bunch from kind of region 6. They kind of do a pretty typical 16 to 20 questions. But we've seen other ones as big as 31 to 36 questions, and so they can be pretty extensive. And the amount of time period that they're asking for information can be anywhere from, we've seen 5 to even 20 years back in time. They've been asking for stuff. 20 years, yes, and some people said but the statute of limitations is 7. It's like they'll ask for it. But whether or not you want to provide that data is something that the facility is going to have to determine the tack that you're going to take with EPA. So this is usually, we hate to say, most of the time when we see facilities get these, that this is kind of that preliminary step into getting into a consent decree discussion. We have seen sites where they submit their 114 request, and then they never hear back from the EPA. And you just say that, okay, and you're always wondering, are they okay with us? Were we not too bad? Did they find somebody else worse?
They're looking for low-hanging.
Yeah, and so it's maybe they said, yeah, maybe you had a little bit of non-compliance, but not enough for us to expend all this energy to go after. And they said, we also, because they send out a lot of these, is they probably found some more important facilities to go after. So there is a lot of uncertainty when you submit as to when or if you will ever get any response back from the EPA. How to handle a 114 request. We like to say don't panic, but at the same time, don't wait. These come with a very specific, they come with a 30-day time frame. That's just the standard. You'll get the letter. It'll say, please provide all this information, and you only have 30 days. Usually there's about a week of time when everybody's just wrapping their heads around what have we just gotten in the mail.
Because, you know, and it doesn't, they don't ask you, oh, do you guys have a turnaround going on right now? They don't want to know that. They just know that you can drop everything and take care of this. So it's, but definitely get moving quickly. Involve lawyers. I know involving lawyers is always not a pleasant thing. But a lot of these things, especially if you have to do any kind of creating any calculations, or you're trying to investigate certain things, and you want to be able to have that attorney-client privilege for those things that you're creating. Pretty much look at the information being requested. They tend to fall into a couple of different categories. Usually there's a data portion of the 114 request surrounding your flare. There's a documentation piece where they want to know, give us any manuals, any design documents you have around your flare system. They want to get it. They're going to ask you for all your permits. They may ask you for all your permit applications. They may ask for emissions inventories. My favorite one is can you ask, please provide any documents you have, known or unknown, that tell you how to operate your flare. How do you know it's an unknown? It's a known unknown or whatever, or unknown known. And so you're going around and you're saying, wait, how can I provide something that I don't even know if I have? So, but they ask when you go look, if you find something, whether or not you knew it was there ever in the past, you have to then provide it. So it's it's kind of a all hands on deck, just find the information kind of thing. Ask for an extension. This is, some facilities are a little concerned about, do we have to have a basis to ask for an extension? It's from our experience, it's pretty much been, you just say, we got a 114, we need more than 30 days, and they're like, okay. Generally that 30-day, people will say, can we ask for 6 months? No, we have not seen any, but yeah, you can ask. But I mean, it's pretty much nobody's getting that. Penalty for being late.
Move to the top of their list.
Yeah, it is. Yeah, I mean, they are looking for a level of responsiveness and wanting to see that you're taking it seriously. If they suddenly think that you're not taking it seriously, or you're not going to give them, do what they ask you to do, that's when they're going to start asking for even more stuff. So they can be kind of punitive with their requests. But I mean, if they see that you're making a good faith effort to get the data, they're going to work with you. So I mean, and we have seen the 30-day to 60-day be relatively consistent when people ask for time. One of the things that when you ask for time is they like to see something. So there's going to be some questions, like the question of, give me all your permits. You pretty much have your permits readily available. Is they want to get some answers. We'll say, we can answer these 10 questions, today. Here's the data from 10 questions, but we need an extra 30 minutes or 30 days to pull together the rest of the data. And they've typically been working with people, but they just want to, kind of see that, yes, you are working at this, you are trying to get it, and they've been receptive to that. We saw a flurry of 114s going to the refinery industry, and then we saw a flurry of consent decrees come out of the refineries. What we've seen recently is they are going almost specifically after chemical facilities now. So I mean, they've kind of shifted their focus. That's not to say that there aren't going to be any more refinery consent decrees. We do know there are going to be more. But it seems like their push has kind of shifted towards the chemical sector. I kind of get a little Machiavellian when I think about how they're doing this. And it gets into that whole concept of setting the floor, the MAC floor, and they need to have so many flares in an industry, operating their flare at a certain means in order to say, it's the floor. Well, if they can get that through enforcement, and then they're going to propose a new rule, suddenly they got their floor through enforcement, and now they have the ability to push through these changes. So I mean, I think that they are, I don't know if it's intentional or not, but it just, you get that feeling that they're using enforcement to be able to change the regulation. Yeah, so, you know, it's moving forward. A lot of different questions. The data side, it's pretty much verbatim between all the ones we've seen. They want to know the flow rate of the gases going to your flare. Usually it's about that 5-year window back, plus or minus. They want to know the volumetric and mass. So if you already had like a GE Panametrics or something on your flare header, then that data is relatively easy to get. If you don't have a flow meter, or if they say if you don't, or you have to describe your monitoring of what you have on your flare system, and then they're going to ask for the data. If you don't have the data, they're going to ask you to estimate it. This is kind of how much work do you do to try to answer the question, because sometimes it's better to not give them information than give them poor information.
What average time do they want that data?
Hourly, yeah. They will also ask for your assist rates. So if you have a flow meter on your steam, you want to get that data, but a lot of times it's people only have, you know, hopefully they have the valve positions for the steam in the DCS or the historian, so they could use a valve percent open to calculate steam flow. We see that a lot. But it is trying to get that data. They're going to ask you to calculate a steam to vent gas ratio. So it's kind of like they make you do the calculations when we know that they're going to just take that information and do the calculations themselves. But they make you do it. They always ask for the heat content of the gases going to the flare, again on that hourly average basis. You know, and then the other one is they always ask for the previous, usually it's like the previous 30 days, they want actual speciated data. And it's kind of like, if I wasn't taking samples, how am I going to give you data when you ask me, oh, they come in today, give me the data for the last 30 days. Well, we don't have any data. We can, you know, it's one of those things, do you want us to get you data? But they're asking for very specific speciated data. So, you know, and again, it's if you cannot provide actual data, is use engineering estimates to provide. And it's taken different tracks on with different facilities, whether or not they just say we can't estimate it. You know, basically it's one of those things that's like, also, can you estimate it within the 30-day time frame? Or, I mean, is it going to take a lot of time to do all the engineering calculations to try to figure out which valves were open and going to the flare at that one point? So we see different tracks on that side. The questions, they don't stop at the flares. There usually are some additional questions. Sometimes we've heard that it depends on how recently someone's been out to do an inspection of your facility. If they were out doing an inspection and they had some concerns about your tanks, there may be some tank questions in your 114. They like to, almost consistently, they start to ask, are you using, do you have a closed vent system going to your flare? You know, they're looking for that LDAR applicability to kind of say, are you using that flare as the control device for LDAR? So that brought you into needing to comply with 60.18. So, I mean, they want to establish that, what should you have been doing with your flare? A lot of times too, and we think that it's coming from trying to justify minimization or installation of some sort of flare gas recovery, but they ask for information like how much natural gas does the facility as a whole purchase, you know, and then they ask of your fired sources, how much, what's the fuel usage for all your fired sources at the facility. And we think they're just trying to create that thing of, they want to be able to create the argument that oh, you've been flaring all these gases and you've been buying all this other gas. And they want to be able to start that argument that, why don't you recover the gas that you're flaring and burn it instead of buying it? So, I mean, they're asking for those type questions. Yeah, they ask about a lot of, like, just they go back in time. Sometimes they're also asking to see, like, when did you make modifications to your facility? You know, then they ask for permit applications. They're trying to see how close were you maybe to a PSD limit? You know, were flare emissions part of that that permitting that didn't trip PSD? You know, are they going to say now you really weren't getting the 98% control, and so the emissions from this project are much greater, and you should have done PSD permitting? So I mean, they're trying to create that rationale for enforcement. Yeah, so that's this is a large effort. You're going to need to have some people pretty much dedicated to this effort, just because that you're going to have people going into the units a lot to get a lot of this information. You know, maybe you need to figure out what's actually going on with the flare. Or you're going to need people to be able to go after different parts of the information. So that whole coordination of the effort to be able to put that single deliverable to the EPA can sometimes it's just a logistical nightmare with all the different data sets that you need to do. But there will be a lot of people involved. Yeah, this is the other one, is how do they want the data? They want you to provide the data in a nice Excel format, because they want to make it easy for them. They don't want to get a bunch of hard copies of data, so then somebody down their end would have to type all that data into Excel. They want you to set up the Excel sheet so you have all the columns with all the data, so then they can speeds up their analysis of your data. Also, any other documents they want in a searchable type PDF document. So it's definitely how you submit the 114. Different people take different tacks. Some people say we're just going to print everything out and send them a couple boxes of information. Other people say, well, no, they want it electronically. We're going to mail them in a thumb drive. Or multiple thumb drives, depending on how much information it is. We kind of think it's a good idea to provide some explanation of the data that you're giving them, just so if you need to explain some sort of nuances, how to maybe this piece of data that you're giving them isn't, exactly what they want. Like if you have valve position, if you have multiple levels of steam addition, but you only have certain kind of information off some valves, you need to be able to explain that. If you don't have the temperature and pressure correction, you got to explain to them that, well, we do have, we can give you on the actual cubic feet, but we can't give you the standard. We can estimate that, but it's not going to be exact. You kind of want to tell them what you're giving them, and so they can not make their own judgments. One thing we have seen, especially with sampling data, is say you said, well, we did sampling on our flare maybe 4 times in the last 5 years. We've seen where they go and say, okay, you gave us that data. We're going to apply that sample for all time until you took the next sample. So, I mean, they will spread the data out over time periods. And, so you need to understand how that, for when you start thinking about, the concept of how much time were you out of compliance, if you have one bad sample and it's going to be stretched out over a long period of time, you may want to have some additional arguments around that. One of the things is they say you have the requirement to provide additional data if it becomes available at a later date. So even if, you gave them everything you thought you could give them, if new data becomes available, you're obligated to submit that. We've also seen many of them where they will come back at a later date and ask for additional data. That seems to be coming from, they want to know, did our 114 request change your behavior? Did you go in and look and see that, oh, we're grossly oversteaming the flare? Did you do anything about it? Or do they come back maybe a year later and say, give us this last year of data and say, okay, you're still oversteaming the flare. Why didn't you do anything to try to reduce that amount of steaming?
I can't overemphasize how important that is, because in several of the ones that I'm involved with, that is exactly what happened. And now that they're getting hammered for not changing their behavior, and the parameters they're looking at are like 3. Is kind of the number they're saying. If you, after you do the analysis of the data, you see you're over 3, and you don't do anything to change that, then if you do move into the negotiation stage, that cripples you in the negotiation, because then they're going to come back and say, we told you this, you didn't do anything, you're being unresponsive.
Recalcitrant. You're being recalcitrant.
Yeah, it's
How does that happen?
a lot.
Yeah.
But, oh yeah, a lot.
I mean, is it
Unfortunately, our attorneys advise us that we're not.
Well, that's the problem. In some cases, that the attorneys are saying, we're not doing anything until we negotiate our approach. I think what you're saying is spot on.
Yeah, because and they'll also take the attitude of, you've seen what we asked for in all these consent decrees. You know where we're going. Why don't you start moving in that direction?
Yeah.
So it is they expect this to start making changes at your facility.
But at least do an experiment. At least you can say, well, we tried to turn the steam down a little bit, or it smoked, or, you don't have to change your operations, but if you just attempt to play around with something, do a little experiment, then you can present that and say, well, we're working on it, we're looking at it, we're at least trying some different options here. But I can't tell you how often I've seen people get nailed with this, where they send in the form and they go, okay, well, we're done with that. Not so much.
Yeah, we have seen multiple times where it's like, okay, you said that you didn't have a flow meter on your steam. It's been a year. Do you have one? It's kind of like, oh, did you guys put one in? So yes, they do want you to start making changes immediately. We have seen, you provide some data. Sometimes there will be some very quick questions back. Just kind of, they got some data and they just need some quick, understanding of what you gave them. They have looked at it and said, no, wait a second, is this or is this? And so some of these questions are just so they know how to handle that data. Other times they will start moving into bigger questions, sometimes asking you to now start sampling some of your flares, things of that nature. So I mean, it can, if they take an interest, they could take a big interest in your facility. But yeah, and also as supplemental responses, usually when they give you a supplemental, they will ask then, please provide all the data since the last submittal. So they're going to be continuously asking for more and more data to look to see for these very changes. At least from what we've been seeing is the end game is, I think, relatively pretty much laid out. Everybody has, you see just within the consent decrees, everybody's, it's kind of, we're all up, playing the same game but using different players. So I mean, everybody's kind of going towards this. They want monitoring, they want control. So I mean, it's that end game is pretty much a given. Now, when it comes to installing recovery and minimization assessments, that's when it's going to be a more deeper dive into understanding, is it feasible? What are the issues surrounding that? So, but the end game with at least monitoring is relatively straightforward. And unfortunately, a lot of time the end game is a consent decree. Other times we have seen the CAFOs come out, the consent agreement final orders. Those are generally seen as being better. But usually to be able to comply with one of those, you have already had to have started moving before they come to you. So I mean, if you're not already working up the engineering to install this monitoring and control, you're not going to be able to get done in time. So I mean, it is really getting out of the consent decree trap is saying, okay, we've seen that we were doing some things wrong, and we're working diligently to correct this. So I think it is a good idea to start moving forward. The negotiations, we see this go different ways at different facilities. Sometimes there's a lot of input from engineering. Sometimes it's handled a lot by just the lawyers. Sometimes there's different strategy in that. And it just how that facility wants to go about it. I can't say whether or not it's one way is better than another, but it is interesting when people, you talk to a site and you say how are your consent decree negotiations going? They're like, I don't know, the lawyers are doing that. And you're like, okay, I hope the lawyers know what they're doing. So it's hopefully there is some back and forth just to understand, what is possible, what is feasible. You don't want to get, into a consent decree telling you to do something that is going to be give you significant heartache. Well, there'll be heartache regardless, but significant heartache. So I mean, at this point, I was just trying to see if anybody, is anything I said, a lot significantly different from what you've experienced out there. I mean, we don't have to talk about. Maybe people don't want to talk about themselves, but I don't know if anybody wants to share. But I thought I'd open it up. No, okay.
Just one quick comment. I mean, EPA believes that for better or for worse, everybody should have known about this flare issue since the 80s. And their philosophy seems to be, all we're doing with this consent decree is pointing out to you that you have an issue. And when you collect the data, it kind of forces you to see that. That's why they then come back and say, well, you should have known about the problem. Now we forced you to collect the data to show that problem exists at your facility, and that's why they come back then and say, you should be acting on this immediately as soon as you've collected that data, because you've got those other two things. You have the knowledge, you have the data, and you're not doing anything. I don't understand that. Why is that? And that's, we've seen that time after time after time. It's not exactly what you want to hear, but I think it's what they're
Is there an expected amount of response data that EPA is expecting?
A response what?
Is there an expected amount of response data from the site that the EPA is expecting?
I mean, they ask for the specific things. I mean, they're looking for hourly average data back at generally.
That's not everybody, or has that happened?
It just somebody said, I'm not going to give you the data.
We don't have it.
No, there's plenty of times where you just say we don't have it. We don't have a good way to estimate that flow. And I mean, that's usually when they start saying, okay, well, we need to, and from what we've seen of presentations by, Pat Foley and Brian Dickens in the past was that elevates you in their minds as for enforcement.
My understanding is that is not a good response.
Yes.
Well,
They will say that, if you tell them we don't know anything about our flare, they're going to come back very quickly.
to the top of the list.
Yeah, so it is, that's where you want to provide as much data as possible. But I think at the same time, you need to make sure that stuff, because it's like, can we do an engineering calc? Is that going to be correct? Maybe. Do you want to lead enforcement off of poor data? A lot of times, some people don't really want to go down that route because you're going to be arguing about that bad data forever. And so it's kind of, other people have said, well, we don't have it now. This is a 114 data request. What data do you have? If we don't have data, we're not going to create data to respond to this. We'll say this is the data we have. We're going to respond with this data. we can now begin the process of making changes to our system to get more data, but, we don't have it at this time.
One of the issues we've had, Conoco, as a company, before we merged with Phillips 66, we had 4 separate refineries, and we entered into a consent order, or consent decree with the EPA, negotiated a number of different specific terms, things like our East Plant flare, which had no flare gas recovery on it. If the flow was so low that couldn't justify putting flare gas recovery on it. The concentrations of HSEU were high, but we agreed with EPA, they said it was okay for us to just stay below 500 pounds of emissions on a daily basis. They would consider that compliance with NSPSJ in lieu of the 160 limit. Now we're trying to close the consent decree, and they're going, oh no, that's not what we meant. We never intended to say that. Why did you guys think that was okay? And they were thinking, well, now we're going to go back and fine them for 12 years for not complying with the 160 ppm limit. When in fact, we have a written letter from them that says it's okay, but they're saying, no, that's wrong. That's my big concern.
We didn't mean what we
Whatever
said.
you agree to, they may not want to agree to it later. They may change their mind.
Somebody
What?
bumped it up to a higher level and caused some heartburn.
Well, apparently that's the case, but all of this negotiations went through Patrick Bowe.
Really?
Never did it. He was the one who said, yeah, it's okay. And now they're crabbing. They're saying, no, we never said that. But
Even
kind of
Foley
right.
has his Lord and Master.
Well, yeah, so, that's my concern, is that they're not gonna be consistent about this, and no matter what you do, they're gonna come back and say, no, we never said you could do that. And I'm concerned, with this being a dynamic thing, we don't really know, we may have to remove the cooling steam from the tips to get good combustion at low levels, right? So, but if you wanna keep the steam in there to make your tip last longer, well, now that's not gonna be okay, even though we have lots of data that say that might be the right thing to do.
But at the engineering level, when that's the situation, and I recommend a change, they're gonna say, well, what do we need to do that for? We have this agreement. So, you understand my problem?
Yeah. So, my concern is the agency being wishy-washy, or for lack of a better word. They're gonna call it about the agreement, and they agree to one thing, it's fine today, and then tomorrow, no, that's not what we said. So, that's the biggest concern I have. So, when you're thinking about these things and negotiating these kind of things, you need to be very careful about the communication, make sure you have clear documentation, make sure it's written, right?
That's what I was gonna ask, like, we take the policy of meeting with EPA, and then we'll send them notes from the meeting. Kind of, do you agree this is what we talked about?
Yeah, but you need that response from them, saying point by point, yes, this is okay, yes, this is okay. If you don't get that, you're setting yourself up for failure. And even if you do get it, you may be setting yourself up for failure. That's the way it appears in our decision. I mean, we had hoped to have it closed last year. Even in 2013, we were kind of hoping we might get it done in 2013, and now it's looking like we may not close it for a long time.
Yeah, getting out of a consent decree seems to be a very difficult thing to do.
We've had all of our closure audits, they've come to all 3 sites, and they've done everything, and they said, yeah, you spent all the money you said you were gonna do, you put in all the projects, we installed 3 flare gas systems at a cost of about $69 million, and we did all this work, and now they're saying, well, what you did wasn't what we intended.
And that just kind of illustrates the point of, if you can get into a CAFO, CAFOs self-terminate. So it's kind of like, if you can get yourself there, you could save yourself years and years of problems.
But you have to be able to do everything in like a year.
You have to do it in a year. So I mean, that's where you have to start running from the beginning.
You almost need to be running before you even get into negotiations, because you can't even design a project and get funding and order the equipment and install it in a year. You can't do that. I mean, especially on some of the long lead time stuff, like flow meters, Panametrics, I think, is quoting like a 28-month delivery time right now.
Because it requires a plant manager flexibility in his capital budget to spend money now.
Yeah. Who has that today?
Right, yeah, and nobody.
2 months ago, we might have had some discretionary money. Today, we
Everyone was saying,
don't.
when do I have to install this? By rule, forget it, I'm not doing it.
Right.
That's a very hard conversation.
Hard sell. It's a very hard sell.
No, I was going to mention on the CAFOs. One thing, it was interesting last week at the conference, EPA Region 6 enforcement indicated that they may be more willing to go the CAFO route, even when there's combustion zone issues, if the other 60 extend past that 1 year, their attorneys may allow them to do that. If you can maybe do a longer plan on to address the combustion and stuff. So 3 to 6 sounds like they may be willing to kind of entertain some more creative ways to meet those combustion alternatives.
Yeah, it would, from limited interaction with Region 6, they seem to be a little more reasonable. Okay, so we're going to jump into consent decrees. Again, probably, I know everybody spends a lot of time reading these consent decrees and looking at them, so I'm not going to try to dive too much into the details. Maybe we can just talk about some of people's topics of concern. Just going to try to talk about, I talked about the 114 request. I'm going to talk a little bit about the period in between the 114 request and the consent decree. Then we can talk a little about the consent decrees, and then just kind of talk about how those consent decree requirements, how they can overlap with other regulatory requirements and how well that overlap really is. So for the, there's been a big thing about these interim measures. This is something that's, come up, and it's the EPA, they not only, so you got the 114 request, you got your data says, okay, yes, you were not below 3-to-1 steam to vent gas ratio. While they know that it's going to take time for you to install the analytical, you're gonna, put in the flow meters, put in the control logic, do all this, it's gonna take time, but they want to know what are you doing in the meantime. And some of these things that they're looking for are more administrative in nature. They're not saying, run out today and put a flow meter on. They're saying, how are the flares being operated? How often are the operators saying, let me see if I can turn that steam down a little bit more? Is it at least once a shift? Is the operator going to go in and say, okay, is that dialed down where it needs to be? They didn't have an event where the steam got turned up and the previous operator forgot to turn it back down. Is there, at least something documented, written procedure to say, hey, maybe it's once a shift, maybe it's twice a shift. They go in and say, okay, yes, it's dialed down. Okay, oh, there was a little smoke. Set it up just a little bit, so they've dialed it back. That's kind of the things that they're looking for. It's more administrative in nature. And so, because they want to know, they don't want to say, well, it's going to take, it takes usually a couple of years to negotiate a consent decree. They don't want to know that, oh, well, you're just going to be poorly operating your flare for another 2 years until you get an enforcement agreement. They want to see that you're trying to fix the problem with what you got today. Okay, I got ahead of myself. Okay, the monitoring assessments. One of the things that, where we want people to try to be proactive about these things is, okay, so you did a 114 request and they asked for, say composition data, and you have no composition analyzer on your flare. Now's the time to start looking, where's a good place to put it? What are the technologies? Start doing that evaluation. Are you looking are you at a site where they suddenly say, no, we hate GCs? Okay, well, what are your non-GC alternatives? Or if you say, no, we really like GCs, go down and see what are the options. Am I going to have to build a shelter for this thing? Kind of those, and some of those questions are some of the bigger dollar issues. So, it's really getting from what do we need to actually doing the engineering studies to do it. There is a lot of, things you need to look at and evaluate, and kind of it will help make you understand what's going to drive the cost. And sometimes that's the best thing you can tell your plant manager is, we've come to these, we've looked, which you can show them that, yes, we have looked through all these different alternatives, and we feel that this package here is going to be the lowest cost with the best data. That's kind of getting everybody understanding the concept of what this enforcement is, and showing that, yes, you need to look at all these different parameters. And this is why maybe we should go with a more expensive route, but it'll work better for us. And so, you know, that's kind of the stuff that you should do on the front end. Always of concern with flow meters, we've heard about it a lot, is just having good placement. One of the biggest things is, you know, if you don't have a lot of pipe between your knockout drum and your flare, you know, you may need to put on, well, you know, our trombone piece. We love that guy. Actually, no, we hate that guy, but it's, you know, maybe that's the solution. And, you know, now you're getting into a much larger project that's going to be more expensive. You know, or is there another technology that you could go with? You know, there's a different mix of technologies, we like to say. The composition analyzer, sorry I wasn't here on Tuesday. I had to teach the other class, but I'm sure they talked about the speed of analysis. And from what we've been hearing from people, the faster you can get your data, the easier it is to control. Dealing with lag time issues is going to be frustrating. So it is really important to use that as in consideration. Looking at sufficient speciation. This question comes up a lot, is to say like, okay, well, why do we care about the EPA has their list of 20 components? Why do we care about all those components? You know, when our composition shows that we're going to be, these are the compounds that are really going to be driving that heat content evaluation, do we need to care that there was 1 ppm of something in that vent gas? You know, you kind of need to be able to do those kind of analyses.
Well, question I have on that is, does EPA care? In other words, I know that one of the reasons for this initiative is to control HAPs.
Mm-hmm.
So if you've got low concentrations of certain toxic compounds, they look at that as that's still an issue. As far as there's no de minimis for them.
We've seen through I know I can think of one in particular, one of the country mark consent decree. They had limited some of the speciation. They had to do sampling to show that these compounds were just, you know, either not there or just rarely there, and that they got a reduced list of compounds. So I mean, it is kind of, you're going to have to do work to show that those compounds aren't an issue. If they're really, like, I mean, it's one of those things, if it's 1,3-butadiene, yeah, they're pretty much going to care. You hope they don't care, but they're probably going to want to know.
Even for things like benzene, which you think they would care about. Marathon was able to show, for example, that they don't have benzene in their flares. It was taken off their list, but you'll see benzene show up on other folks' lists.
Mm-hmm.
It's possible.
Yeah,
Right, you need data.
yeah, you need data, and you need to work. And it's like it's a negotiation, and don't gloss over the details, because it's the details that are just going to kill you. I mean, we see that with the proposed changes to Max CC. You like, on the face of it, it looks like, okay, we see some of the typical concepts, but when you get into the details, you're like, oh, that's a headache. And it's just, you know, going through all those details, especially in an enforcement negotiated position, is kind of, you know, sometimes you get what you want, sometimes you don't.
I mean, that original list in the Marathon consent decree, you know, it came really from Marathon's specific situation, because they had GCs already on some of their flares, and that was used to develop that list. That doesn't, and that doesn't apply at all to shouldn't to the chemical industry, right?
Mm-hmm.
They're very kind of different flares, but I mean, so in terms of getting stuff off in that regard,
Mm-hmm.
as they're moving into the chemical industry, that's going to become more important. It's obviously a refinery list
Yes.
of chemicals that they have.
Yeah. When we go to chemical facilities, I mean, and we see with those flares that they usually have a much narrower band of chemicals, and so, you know, that's a good argument to say we don't need to look for all these things.
Especially
We need to.
if you're gonna put on a GC. I mean, because anything that's on that list, you got to calibrate for, which really is a huge.
Yeah, and the larger the compound, the longer that runtime is. I mean, if you got to run a GC for benzene, you got a long analysis time. So I mean, it's you need to.
Caveats a lot. Because in the wintertime, the heavier stuff will condense in the bottom of the bottle, then the concentration, certified concentration will get.
Mm.
You gotta have electrical plugins, more power, more conduit, all that stuff that goes with it. Starting,
Mm-hmm.
you know, a system that'll be active.
Yeah, we know.
use a GC.
Yes, yes,
IMAX system, that looks like a pretty good option, who knows?
yeah.
There's new technology comes along, it just doesn't, it doesn't come along fast, doesn't come along every day.
Yeah, and I'm sure Troy talked about this yesterday, but that's where it's scary with MaxCC, where they wrote the rule for a GC, and you're just like, really? That's kind of at least I think about like that's the old technology. It's like there's so many new things that are being shown to work much better. Why are they writing a rule for a piece of equipment, especially if it's a technology rule? It's supposed to this rule is changing because technology is changing. Well, why are you specifying a technology in a why are you limiting people to one technology when we're supposed to be keeping up with it? And it gets there's some frustration out there, but
You think they understand
yeah.
this technology, and they're coming. Right.
yes.
This new stuff, well, they haven't had a chance to soak on it
Mm-hmm.
and understand it, so.
Well, I think it's also the big difference between a SEMS and something used for control, is they understand SEMS. They understand measuring something and getting a data point to show show compliance. They don't understand that compliance point isn't coming fast enough.
They are allowing, though, this newer technology in the consent decrees. I mean, we were able to get an FTIR into SAVIC, and we actually are trying to get the IMAC instrument into another consent decree. EPA has already agreed that they will accept the IMAC technology in a consent decree. So, I mean, this is different than, the rulemaking, because it's a specific negotiation. But conceptually, at least the OWECA folks seem to be open to looking at these other technologies other than GC,
Mm-hmm.
which is
And
nice.
it really just doesn't make any sense that they would specify a GC, because there's a process and rules already for certifying and approving new technologies.
Mhm.
So why would they say any technology that meets this criteria or this standard is acceptable?
Mm-hmm. Yeah, and that's the big difference we just see when dealing with enforcement versus rule writing, is the understanding of the technology is a little better on enforcement. Control assessments, especially steam and air. Is people have had these systems set up, and the question is with the control system we have set up right now, is that going to be adequate? That's going to take some thinking about what's the quality of steam you get. Is steam going to your flare for reasons other than controlling for smoke? We've come across this at a couple of different places where sometimes the flare is the easiest place to get rid of excess steam. That's definitely something but then of course that is another big project. So it's, you have to think about these things holistically. Checking out, okay, we have some ROs, we got our bypass ROs, are they still valid? Does anybody pull those things out and check to make sure? Doing that, and I think doing that evaluation to say that yes, that RO is sized properly and is providing that minimum cooling steam is a good thing to be able to show the operators so they can feel comfortable saying, I'm not going to burn up that tip if I turn the steam valve all the way to zero. I think they have an uncertainty with that. We talk to the operators all the time, and they're like, you get that response of, you see the RO, you see the control valve, and they're like, oh, we always leave it about at 5% or so. We want it because we can't burn up the tip. And it was just like, but you don't want to argue with them. We're not going to get into the details, but it's like, you're thinking to yourself, but you got an RO that should keep the tip from burning up, but it's still in their mind that they got to keep that valve a little bit cracked just to keep the tip safe. And so it's being able to show them that no, maybe somebody from their engineering group to tell them no, you're going to be fine with just your RO. That could be a good thing for helping dial back that steam. The other thing is looking at the number of control valves on your steam. Do you have that ability to fine tune the amount of steam? We really saw that in the preamble to MaxCC when they were talking about that base case of minimum steam and minimum purge. They didn't come out and say add more supplemental gas. They kind of said, Well, we feel that you really need to dial in your steam a whole lot better before we're going to say whether or not you need to be adding gas. So I mean, they're really looking for a fine level of control of your steam.
What's your sense for how many people have the ability currently with their valving to get the level of steam that really allows them to respond? Most people have this already, or
It's a mixed bag. We've seen a lot of different things, and it goes from the range of a manual valve on a 4-inch high pressure steam line, where we can go, okay, so what do you do when it smokes? And the guy goes, oh, we come out here and just open it up a little bit, and we're like, so how much? And he's like, oh, it's usually about like this. And he goes and turns it, and then we get rained on. And it's just like, oh, okay. That's a lot of steam, but I mean, it wasn't even a quarter turn. I mean, we're talking about he just barely cracked that valve, and the steam went crazy. Other facilities, no, they will have, the bypass RO. They'll have a control valve. Sometimes that control valve is too big. It'll be on a larger 4-inch line or something like that. Other times, you do see a facility where they was set up where they have like maybe just like a 2-inch control valve, and they through the multi-tiered levels of steam addition, they have a finer amount of control. I'm always, with those bigger tips in the multiple places of steam injection, I always just get concerned about that minimum steam, because there's a minimum steam for each addition point. And, sometimes you're getting upwards of 1,000 pounds of steam minimum going to this tip, and you're just thinking, that's a lot of gas you got to be putting up there.
Does that come from the flare vendors? Because I thought most of the flare vendors were concerned about minimum steam just as a function of center steam. But I've also seen that in some cases where they have minimum lower steam, they have minimum ring steam, and I'm wondering if that's the plant that puts those on, or is that?
It's on the flare tip drawings. It's from the flare tip vendor. Yeah, that's pretty much typical. We've seen it starting to disappear from some of the newer tip drawings, but in most of the time, it's each level of steam has a minimum cooling steam that's required. And so when, even though the plant, a lot of times they like to just use that like lower ring steam if they have a big flare with the tubes. They'll like to use that steam first and predominantly to control for smoke. But they're still got like 500 pounds an hour of minimum steam going to the ring, going to the center steam. And so, it can be a significant base load of steam going there. And so, but then you look at the purge rate, and it's not that high. And so,
Where there's a cooling steam nozzle, it's bolt in it, it's set at 7,600 pounds an hour.
mhm.
That's the vendor rate.
Is that driven more or less by mechanical integrity issues? Or trying to keep things from getting too hot?
Yeah,
That's pretty much it.
And then also to keep the flame out of the, top of the flare.
Mhm.
A lot of time you have to have steam in the pipe to keep it warm so that it doesn't cool
Yeah.
off so much when you need steam, you don't shock it and cause some problems. So there's a lot of things going on there. It's not just cooling the tip, it's looking at the whole steam system.
Yeah, you've seen like water hammer issues.
You don't want it to freeze up.
Yeah. So I mean, and that was probably, yeah. So there are issues where you want to keep at least some steam going through the line at all times, but we have seen folks that have gone back to the flare manufacturers and said, is this really the minimum steam I need? And we have seen cases where they've come back and said, well, we think that you could still have, even they've reduced that number, but it's had a request. So it's
Zinc has a technology now that reduces, they have this minimum steam reduction system technology. I don't know how widely it's employed, but that's supposed to significantly cut back on the amount of minimum steam.
Yeah, I think that it'll lead to innovation in the flare tip manufacturers. I think that this issue will become, something that people are going to be working hard to fix. So it's something that'll happen.
Hey, real fast, one of the things that Bruce, you keep bringing up is the flame is existing below the ring steam.
And one of the things we hear is why we don't want to reduce the minimum steam, is because they don't, at least in the refinery sector so far, we're spending a whole lot of time, they don't want the flame down below inside the tip, but it degrades the metallurgy too fast. So that's why they want the center steam to push that flame up. And so it is an interesting thing that you point out, that some flames hover inside that flare tip.
Well, the flares I was showing, it just had rim steam
Rim only,
without
center.
the tubes.
Yeah, but in the refinery sector, they add that center or the upper,
Well,
and they
we have
want to
it.
push it up.
There's a nozzle down below the tubes, and then there's the tubes, then there's the nozzle up top. And so that nozzle below the tubes is just a bullhead nozzle, and it's just pushing steam up around the tubes, keep everything cool.
But we've made several phone calls to Zico, Calidus, and say, some of the sites, they are thinking, maybe we should just turn off center steam. Can we turn off center steam? And of course, the manufacturer's been saying, you can turn it off if you want to, but the flame's gonna suck down inside the tip, and that's dangerous, and it's gonna degrade the metallurgy faster, and then we're not gonna stand by our warranty. Because that's our minimum tip.
But do they know that for a fact, or are they just making assumptions?
I'm sure they know something.
Well, I've got some interesting photos about what happens when you turn off center steam when it was done accidentally. It immediately goes down into the tip.
I mean, at some point in time, there's gotta be enough, I mean, I ask this question, I go, at what point does the big gas have enough momentum where you don't need center steam? And nobody seems to be able to answer that question. I mean, cause I look at the barrel of that flare never got hot. There was a shipping package on it, a little plastic shipping package on that barrel of that flare. That thing stayed on there the whole time, about halfway down. And I was checking the temperature of that barrel, it just didn't get hot, even when we had the center steam on. So there's gotta be a numerical number that the vent gas has enough momentum to get out the tip and not use that center steam. And it looks to me like that's be a huge competitive advantage coming up from the manufacturers, if they come up with that. And that center steam killed the efficiency. It's just throwing water on the fire. Killed it. And that's what, I think that surprised everybody up there. When we turned that, we put, it was 500 minimum on the upper, or on the ring, and 500 on the center. Then we put 1,000 on the ring, and it was a lot better efficiency than 500.
There's been a lot of discussions over of the steam to vent gas ratio, which injection point affects combustion efficiency more or less. I think a lot of people would argue that the center steam has a greater influence than tip steam, but we're not sure if we can, I mean, I don't know. The only one who's really studied this are the VTCQ. There's been a couple slides in the study before about it. And everybody's asking us, how about we just turn off center steam, in which case the amount of steam on the tip is irrelevant. We only need to monitor or measure it, because it's not impacting combustion efficiency. I don't know if that's true. I think that's maybe the pendulum swings a little too far. It must influence somewhat, but I don't know if I can be crystal clear on that distinction.
But we've seen flares that just have, I didn't even think any of these flares existed, but there was a flare that had the upper steam but no center steam and no lower steam. I thought it was a sizable flare, it was like 40-inch flare. I think a 40-inch flare with no center steam, but they do. And even that upper steam by itself affects combustion efficiency. It's clear that combustion efficiency is being affected, even though, it's going on and you don't think it's interacting with the steam, but it does. Or the plume.
I wish we had put thermocouples on that flare barrel.
Yeah,
To see
that would have been interesting.
And right now, I mean, there's all kinds of remote thermal imaging, for temperature. Can you put that on the barrel of flare and?
Didn't you have a TCQ? You
Oh,
were
yeah.
going around with your little gun, didn't you?
Oh, yeah, it was intrinsically safe.
Did you get us out?
I got a bunch of readings on that.
The thermographer can take a point measurement on the barrel, we've done that.
And if it's cool enough not to hurt the metallurgy component, can you turn that center steam down or off until the barrel heats up? I mean, there's gotta be a point where you don't need that center steam, I'm assuming.
Well, it depends on the velocity of
Yeah.
the flare too.
But if you could monitor through a remote temperature measurement that barrel, and you want it to be no more than 300 degrees, and it's less than 300 degrees, can you turn that center steam down or turn that center steam off until it hits 300 degrees and turn that steam back on?
You know, these are the guys you gotta talk to then, because they're not gonna worry about, the integrity of whether they're gonna keep their guarantee or not. That's always been the problem,
Yeah.
is the vendors. Yeah, the vendors are very, very touchy about burning up the tip.
Sounds like a research project, who wants to pay for it?
Yeah, there you go.
Right.
Well, wind affects the temperature of the barrel, okay, in our case. The highest point was when the flame was blown away from the hotter spot on the barrel. So we walk around the flare, and the hotter part of the flare was when the wind was blown away. That's what we measured.
So the highest temperature was on that downwind? On the
Upwind.
Upwind side. Upwind side.
Yeah. I need to think about the fluid dynamics, but that's where we measure the maximum temperature.
You probably use swirl inside the tip. And it's, you got some crab you going on inside the tip, on the upwind side.
Right.
It's drawing the flame down.
Right, and then the radiance pattern on the thermal image, we just need a higher tip velocity.
Start flaring more.
Add more gas.
Yeah.
It's only money.
Well, the temperature wasn't excessive, it was 300 and some odd.
Yeah.
You know,
But
so-
it's just interesting from a fluid mechanics perspective that the high temperature was on the upwind side, not temperature.
Right.
Intuitively, that seems odd.
Right, and then what you're saying is it was rolling down.
Inside,
Right.
like this.
Right,
Yeah.
right. We didn't have enough flow.
Yeah, and a higher plus, of course, I mean, I guess it begs the question is, we know we can probably do a reasonable job of controlling steam to vent gas ratios at, if you've got proper steam valves, control valve stuff, at higher flow rates when you're having a flaring event. But it's day to day, when you have nothing going to your flare, that becomes problematic. And so what's the total amount of emissions you have? Is it significant enough for us to really worry about? Okay, so we're only at 90% combustion efficiency, we don't have a lot going out. So as long, I mean, I feel like it's not a non-issue, but I mean, it's, in the overall scheme of things, it's a smaller issue to worry about the day-to-day stuff, and whether that's exactly right versus big flaring events. A big flaring event, you'll vent 100 times what you would in a month in a few hours. And if you're not controlling it then, yeah, there's some significant risk of exposure. But if you can control it well during those big events, why do we have to worry so much about the smaller?
I think
Or the smaller non-events when we're not doing it?
I think it just gets back to what's been represented in your permit applications, and if you're willing to take a lower combustion efficiency when you permit something, then are you have you violated something? Yes. Everybody's always driving to find every little point where you can get some emissions reductions, so you can get your big project through. Would they be willing to take a 90%? I mean, that's gonna usually people aren't gonna want to do that.
We just talked about on the steam system at low flow, and what is low flow steam? Why should EPA be telling us anything? It's our problem to figure out what it is for our flare. The business of guidelines, it's a function of the steam system, the insulation and all that stuff. So there's no one answer. What he does and what I do is gonna be different. So why should the EPA even?
Yeah, what they could ask for, does everybody need to test to show that their conditions are gonna work?
Minimum steam, the procedure from the vendor, okay, is to do it at night, turn it up, and minimize the red zone. And you have to do it at low flaring, minimize the red zone at the top of the flare. Set the steam at that point. So you gotta do it in the winter and the summer. Okay, because it's gonna be greater or less in the winter and greater in the summer. But that's the procedure. So that's gonna be different for every flare system. So why, see, I really resent when the EPA gives me engineering recommendations. It's not their purview to give me engineering recommendations. Period. now keeping all these variables, how can there be uniform way to do this?
Yeah, I think it will be finding, I mean, all rules are trying to be written for every situation, but, you know, there's going to be high variability in these situations. But, all right. When it gets to air assist control, it seems to get even more complicated, just because when we get into, you know, a lot of times you see an air assisted flare. Usually they aren't just single speed. Sometimes the blowers are single speed. A lot of times we see dual speed. If you're lucky, you have 2 blowers, so you have maybe 4 different speeds that you can add air at. This one it's funny that air is similar to steam in that you need to still have some sort of minimum air going up in your flare, because you need to keep that upward velocity in the air plenum, because otherwise you have the potential to bring down combustible materials inside of the flare. So that is, so you're always going to have some minimum steam, or not steam, air. We've seen where they, talking to some of the different flare vendors, they kind of recommend having a small blower in addition to the larger blowers that's going to be providing that minimum upward momentum of air to keep that system safe, and then have your larger blowers that'll kick in when there's actual flaring. We've seen different types of and everybody talks about the best, I guess, is variable speed blowers. We've seen 2 different types out there. One where the drive, you're varying the speed at which the vanes are turning. We've also seen the variable vane technology, where the motor's turning the same speed, but then the pitch of the vane is actually changed. Those get, I think the variable speed drive is a little more straightforward. The variable vane can be very complicated in that every different pitch on your blower has a different fan curve. So finding that, knowing the pitch, and then being able to find that blower, or how much air is coming from that different, you're dealing with different curves at that point, so it can get pretty complicated to try to get a good control over that air.
So what's the,
What kind of adjustment control are you seeing out there? Just because somebody's got a variable speed fan on their flare, if they're not properly using that, it's not really that effective. So what kind of control are you seeing out there?
I mean, when you have one that is a variable speed drive, it's usually tied off a flow or a pressure in the header, where it'll increase that rate.
So there's some feedback or
Yes.
what they need to do?
Yeah, but that's the exception most of the time. I wouldn't say the variable speed isn't that common out there.
If anyone around there, I mean, I've got 3 of them.
All the new ones seem to have.
Yeah, maybe if you bought it a while back ago, but if they're a newer flare, you're gonna more than likely have a variable speed blower.
Okay, yeah, we've seen a lot of the older generations, and variable speed isn't what we see.
Are you seeing any retrofit to a variable speed fan?
And that's what we talk to a lot of people about.
What's the feedback on that? Because, I ain't gonna lie to you, we got a lot of video of these air assisted fans, huge plumes come off you. There's just, it's a high speed fan, and it's just ridiculous. So what kind of feedback are you getting when you talk about that?
It's just a cost. It's a high dollar issue to put on that variable speed drive. So it's not that people are resistant to it. It's just getting a comfort level with that amount of cost that they're going to have to do. Because sometimes it's not only updating the motor, it's also having to update the whole blower.
But this is not small dollar cost. This is not discretional capital. No, it's not, we're not going to do this for less than $100,000. It's not something that a plant manager is saying, the big scheme of all the stuff going on in the plant, I can spend a little bit of money and change out this. It's turning out to be, it's a major engineering. And in some cases, what they have is not usable. The fan is at this quirky angle that directs it down. And so there's not enough path length, there's not enough this, not enough that. I got to change the foundation. I don't have that kind of power. I don't have this, I don't have that. Turns out to be, well, just tear this whole thing down and build me a new flare. Now we're talking major dollars in engineering, so people aren't doing it. Now, maybe on the oil patch would be different, but a chemical plant, it's all slow process.
Have you guys seen like, I mean, are you guys having to go through a lot on the fan curves and getting these variables to be blowers set up right?
We haven't seen that work yet. The fan curves, we haven't seen that work yet.
Oh, okay. Me neither. I made up my own.
Yeah.
Drawing the amps and trying to figure out what that correlates to is just so wildly, just a wild west, so.
Yeah, and so it's looking at, thinking about, do you then try to get some sort of measurement of the airflow instead of trying to rely off of the fan curve? That usually is, you're installing some sort of, extension piece off of your blower to try to mount some type of,
No, we did real well with the, like, setting the fan curves, but when you put in the manufacturer's fan curves, it never works. Now, we set up our own fan curves, and it's been working really well, but you have to, the operators always say, oh man, our automatic never works, you always have to put it auto, and that's not true. We finally, after turning on the flare, we finally convinced them, no, you're taking it out manually, you're putting it auto, and then we just adjusted the curve with them as we were doing the startup stuff for the rest of the plant. And by doing our own curve, it worked really, really well. But we had an IR camera operator out there shooting it, and we were having to be very careful about smoking and how long we smoked in 2 hours, but it took about a week or so when we got it dialed in.
mm-hmm.
But we could vary the flow a lot because we were doing purges and that kind of thing to get the plant started. So we kind of knew, hey, they're going to do a big blowdown that we can, adjust up and down to get our flare from curve set from high to low.
Mm-hmm. Yeah, because it just gets into that comfort level with the numbers. Like if you're having to do calculations to show compliance with parameters, it's how being able to show how you got that data.
How we got that.
Like, if you're going to have to, in the equations, you're going to have to say how much air you're putting to that flare. And if you're using a different fan curve than what came from the manufacturer, how do you know what number that is?
Well, I mean, they say like if it's on so much percent, then it's like this much air.
Mm-hmm.
We just set differently on how much percentage we are on what kind of pressure, that type of thing.
Okay.
Because their fan curve that I'm talking about is like, you need to be at this percentage of this pressure. And if you do that, we found if you use their fan curve, you'll smoke every time. Or usually like you're smoking on one end and over air on the other.
Yeah, it seems like it's going to be a iterative process.
We had a flare that our investigators never ever saw lit. The only thing they saw lit were pilots. And come find out, it was impossible with their fan situation to maintain any type of combustion. So probably since the day that flare was turned on, it's sitting at 0 DRE with a 99% DRE reduction on the initial inventory. We never saw it lit ever. And finally, they went in there and retrofitted a LSP fan. And according to our regional staff, it probably is not 90% or 99%, but it's a hell of a lot better than it was. So, I mean, it's very frustrating to see that over and over and over. And, well, we're 6.1 compliant, we're 6.1 compliant, well, I understand that. So, why is it not burning? Why is there no flame on that stack? Well, we're 6.1 compliant, then the lawyers get involved. The lawyers get involved in a technical discussion. Then everybody clams up, and it's very frustrating to see these over and over and over. Dumping ethylene into our airship and using it.
Mm-hmm.
It's difficult. I mean, I gotta bury my saddle with air system flares, so. It's a big one.
Let me ask you a question about the direct monitoring. You got, down in the booth area is Ed Waddington's got a booth with, what is it, ERC, I think.
Yeah.
He's selling a pitot-based system for air monitoring, and I've never seen one installed in the refining industry, although he claims he's got clients for that. Have you ever seen?
I haven't seen, I didn't see that technology.
Is there any reason why you couldn't use a pitot pitot-based system? I don't know if anybody's used one, or is there any reason why you couldn't use a pitot-based system in a?
Just to measure the flow.
Yeah.
For the fan. It would work if it's designed properly.
Yeah.
We have some pitot tubes and some gas streams in our plant, not a lot, but there are some streams where we do pitot tube versus a cordless.
Yeah.
And if they're set up correctly, and proper, the issue on this, it's like probably gonna be upstream, downstream distance, you know?
Yeah, yeah.
They're not,
Right,
they're not
you gotta be
terribly,
really concerned about the distance.
they're not terribly accurate, but if you put in flow straightening vanes, then you can reduce that significantly. And so, if it's designed properly, I can see why it wouldn't work, but it may take some extra cost with flow straightening vanes, whether you wanna shorten it up so it's not a, 20 or 50 or 60 foot pipe, trombone, if you will, to get the flow straight.
There is, for the bigger ducts, there is a multiple hole flow.
That's what I think that's what he said.
Oh, an annual.
It's an annubar type
It's
thing,
like
right?
an annubar, but, and it's been around for,
Forever.
decades.
Yeah, I've never seen one used, and it was interesting to see Ed down there in the exhibit hall, because I didn't think that technology really was deployed in the.
Well, I stopped and talked to the man and got the whole rundown. I actually have an idea for a flare test coming up. The deal with the air flares is it's internals, right? It's not an open flame, it's not an open pipe to the stack.
Yeah.
It's a pipe and pipe. And so trying to figure out which zone has air, which zone has the fuel gas in it. So trying to figure out if I could put his pitot tube in the air portion only after the fan. So instead of the current idea of putting an OSI before the fan, before the inlet. So I got the nice card where we're going to tinker on a couple of pipes.
Yeah.
A way to get a flow measurement inside of pipe and pipe.
Well, there is an instrument too that's a cross face, so that you can hold it up to the face of the fan, and it's 2 eating bars like this. And then you just march it around the dot. Okay, and I've done that. So there is that kind of instrument.
I think, curves meters, use those for flood navigation.
What kind of meter?
Curves, KURZ.
Oh, I think I've heard of that. Never seen one.
Yeah, you just gotta make sure you keep bugs off,
Yeah.
like on the inlets.
Yeah. Huh. All right. That's interesting.
I might have one comment.
Yep.
Air. At our test, the air flares made a lot more particulate than the steam assist flare. It appears to me, the root cause of that was there seemed to be poor mixing of the air at the tip. And you're creating zones where you're not getting the right air. Is there any way to put mixing tabs or something like that on some type of, something on that piece of metal there to create some turbulence as that air vector is coming out? I mean, is that, I've never seen anything like that on top of the tip. Is there a technological issue with that, preventing that?
When we did the component section, we showed you a couple of air tips. Some of the ones that go through the computational preventive along with Zico and zinc and Galveston, those are really interesting. I know they do a lot of work on that mixing. Some of the, I don't want to use the EPA's word, Kmart flares. Maybe some of the Kmart air flares don't go through that. Maybe they don't have as much mixing. I don't know.
Probably comes at low flows with those pads. The mixing, at low flows, it's difficult.
Yeah, you can design it for low flow, but then you won't get it for high flow or
Yes.
vice versa.
Yeah, I think there's just going to be some more technical innovation that's going to happen with air flares.
Pressure assisted flames all goes away.
That's right.
Put it in a ground.
Then when you get to on more of the control side, so you got your steam, you got your air control. What else can you control? And that's your supplemental fuel. One of the biggest things we see is having sufficient amount of natural gas out at the flare. That seems to be sometimes an issue. There'll be a little 1-inch line that's been run out there for the pilots, but if you want to add a significant quantity of gas, those lines are just not run out there. And we always get that question of, well, can I just inject this extra gas up in the header? Like way back in the process, and we're like, well, you can, but that just means that it's going to take that much longer to see any result at the actual flare tip. and it's just going to mean you're going to be dumping a whole lot more gas into the flare because you have to overcompensate to get something to happen fast. Also, just quality and quantity of gas. You know, it's kind of like you look at when you do the calculations for the how much supplemental fuel you need. I mean, sometimes it's a big pipe. I mean, it could be a 4-inch pipe. I mean, it's you know, how big is the pipe coming into the plant? You know, and can you, even if at the worst case, you know, if you want to put a ton of gas there, is that much available, or are you just going to shut down the rest of the plant because you've just robbed everybody else of their fuel? So I mean, there is an analysis that needs to be done over how much gas you have and can you get enough there.
Can't you deal with that with the averaging time of what you're controlling at?
You mean like just for compliance points?
6-minute averaging time, 10 minutes?
It just gets when you're adding gas, it's adding dollars, and people want to be able to reduce that dollar value as much as possible. So it's you know, it's when the numbers start rolling in, people are going to be wanting to dial it back as much as possible.
Control rooms where they express the gas addition.
Yeah. Yeah. So it seems that, you know, people, there are ways to get the gas in there, but it's, you know, to be able to control it and limit it is really getting it as close to the flare as possible and of sufficient quantity. But then, of course, that has its own issues with control valves and flow monitoring. So, I mean, it's another system that needs to be designed. Then you get into just the control logic. I'm sure they talked about it on Tuesday. One of the biggest questions we start seeing is people saying, do we want to do all that in the DCS, or do we want to try to have some sort of external DAS that does it? Some people just say, no, we want it in the DCS. If it's going to be doing actual control, we want it in the DCS. Other people say, my DCS is maxed out. I don't want to have to do, you know, I don't want to have to put all these PI tags or all these tags into my DCS. But you can set up an external DAS that'll, you know, just output the few variables that you need, that the operator would need to know about to make sure that he can keep that system in control when it's not working right. But keeping most of the data out of the DCS. Then it's just looking at, you know, keeping your system in manual versus automatic. I mean, that's a consent decree issue. And then the reporting is also, that's another reason for that, you know, maybe moving towards the external DAS is just, you know, the CDs will have a ton of different averaging periods. So, I mean, you're going to need more of that just raw, you know, high frequency data, and then take that and post-process it to get all your reporting requirements. So it's definitely something that should be considered.
Are there DAS vendors that are getting into the flare business specifically for
We've been talking to some. So it is an idea that's out there, and people are moving quickly towards that.
Dumbo, DHS stands for?
Data Acquisition and Handling System. Then the next thing is the minimization assessments. Generally, you know, with the refineries, it's always, you know, you're looking at whether or not you need flare gas recovery. On the chemical side, I think it's going to be a lot more complicated because it's just going to be what types of gases are there, what can we do with those gases? You know, are these gases that are suitable for your fuel system? You know, that's a big question. And so it's you know, there may be, you don't see a lot of flare gas recovery on chemical flares. And I was talking to one of the guys from Zinc yesterday, and he was saying that, you know, because like they said in their presentation that it was, you know, more regulatory driven was driving a lot of these flare gas recovery systems at refineries. He says it's because there hasn't been a big regulatory push with the chemicals yet to get where you're going to get those projects in. So maybe that will start changing as more and more of the chemical guys get into get to come to the party. Big questions are quality and quantity of gas. I know Roger's going to talk a lot about this, so I'm not going to talk about this in any detail. Just one, and the level of recovery, trying to say you're gonna recover at normal operation. I think Rogers can show, normal is not constant. But then it's are you also going to be trying to control for startup shutdown, some small emergency type situations? We've seen people going through this analysis, and some of the numbers that they start saying is, well, we want to be able to, capture at least 90% of all flaring events. And you're just like, how many compressors is that? And they're like, oh, it's at least 5 or 6. And you're just like, wow. How many are going to run normally? Oh, maybe 1. And you're just like, wow, that's a lot of compressors to put in. But yeah, so it's going to be, people come at this through different, from different places. Another thing to look at, is the at-source reduction. I think that there can be a lot of work done here. Just get those flows out of the flare. Just one of the things we've come across through our work is, people talk about PSV leakage. Do not forget about the bypasses. Those are where, the PSV gets changed out every 5 years. Does anybody ever change out the bypass? Probably not. So, I mean, there's a high rate of leakage for those sometimes. Another place where we see a lot of some, when we're doing our minimization assessments, is where are some of the larger contributors, and the next thing is looking at like control valves. And one of the big thing is like on your fuel gas mix drum, with your purchased natural gas, there's usually it's run off of a pressure control to back out the purchased gas. But there are plenty of sites that, we go to, and they say, well, we're long on fuel. And I'm like, well, are you buying gas? And I'm like, yeah, we buy gas all the time. It's like, well, why are you buying gas if you're fuel long? And so, it's kind of, is that logic set up with the controllers to back out the gas you're purchasing when you don't really need it? Another one that we see kind of commonly is that control scheme where you need to keep like a natural gas blanket on a vessel. And we've come and looked at the control valves, and we said, like, why is this always going to flare? And it's like, oh, and then they go in and look, and either maybe there's something leaking by the inlet control valve, so it's constantly adding too much gas that's overpressuring the vessel, sending it to flare, or that control scheme is not set up well enough, and that they're ending up putting too much gas into the vessels on a consistent basis. So just a couple of quick ones that we come across more than the most, I would say. Scheduling. This is not a short process. You got to take all these different things into account. Especially if you're going to go flare gas recovery. Roger's going to talk about that time frame. Just the time to go through the other engineering assessments. The MOC process. Everything's got to be reviewed by everybody. So that's just going to make these time frames longer and longer. That's also why you need to start sooner and sooner, especially if you want to avoid a consent decree. Is you cannot say, okay, well, us to get through this process is going to take a year or two. Well, you may be beyond getting a CAFO at that point. So, I mean, it is start getting these processes moving. And the other big one is the turnaround, especially when it comes into things like reworking your steam lines to your flare tip. That's likely going to take a shutdown of that flare. What is your schedule? Do you have one coming up in the next couple of years? What can you do now? Can you at least install the taps for some of this stuff? When people don't like doing hot taps, is do them when you can. Get those things into the schedule. You don't have to engineer the whole system, but at least get the taps engineered and installed when you can. That can save you a lot of time and potentially a huge amount of money. Okay, I think I'll breeze through these. I don't know how we're doing on. Okay, we got like 20 minutes till the break. So we've everybody's seen this table from us before, just showing that the document length. It's always something. It's a lot of requirements. There's a lot of specificity. There's a lot of things to do. Sometimes the penalty is not an insignificant amount of money, and sometimes it's an excessive amount of money. So it can be a lot of dollars. Sometimes the dollars in the penalty isn't really reflective of how much money was spent by the facility. Sometimes they did a lot of work before signing the consent decree and getting a penalty in order to get a lower penalty. So I mean, those dollars do get spent. So it is an expensive thing.
Well, in the case of, you look at Marathon versus BP, I guarantee you that, I don't know, I guess they did a lot of flare upgrades too. The cost of the testing that Marathon did that got them that reduction was nowhere near $7.5 million.
Yeah.
So that money didn't get spent on testing.
Yeah, so I mean, it could also be that good faith effort. If you're putting the effort in to try to solve the problem, maybe they back off on the penalty a little bit. So
the testing wasn't in that $460,000?
no, this is strictly the penalty. Everybody's seen the consent decree. We know that they're all going to follow a basic structure. The two biggest components. One side is instrumentation and control. The other side is minimization. That's pretty much standard. And even at this point, the monitoring and control is getting pretty much standard. So it's more the minimization side that's going to be different. But each one has it. Whether or not there's going to be combustion efficiency testing, I think we've seen that going away for the steam-assisted flares. I think it's for the air-assisted flares. If you have an air-assisted flare and you're getting into 114 or getting into consent decree discussions, you can pretty much think that they're going to ask for a test, just because they want to learn more about how you can properly operate that flare. Stipulated penalties, and the final one, the requirements, they live on forever. The last step to the get out of jail free card is, you didn't get out for free, but the putting all those requirements into your Title V. So then, as we know, once you have something in your Title V, it generally stays there forever. So you get these requirements forever. We provided these tables again. I don't know if there's anything specific we want to look at. It should be in the handout section. Looks like steam to vent gas ratio. Looks like they gave up on doing it on a volumetric basis, pretty much mass to mass. Everybody gets the combustion requirements. Exit velocity pretty much stays in there. Everybody's going to have to do the DCS logic to do the automatic control of supplemental gas assist. That's pretty much consistent, because it's kind of like when I start saying this is consistent, this is kind of saying, guys, this is what they're going. This is the end game. This is things that are not going away. So those are kind of things you can focus on if you want to start doing things now. The video monitoring, that seems to be, they went from only needing it if you were in manual mode more than 5% of the time. It seems in the last couple that recording of the images has become kind of consistent, the 4 frames per minute. So that's kind of coming to happen. You can see there that the performance testing isn't a constant. I know with the Flint Hills Resources one, I mean they set a lot of their parameters based off of their testing, so that one's a little bit different. Everything else is nothing too crazy. Just the overlap between some of the flare rules and flare CDs. When it was JA, you saw there were similar things. In a consent decree, you're going to have a monitoring plan that you got to submit, and you're going to have a waste gas minimization plan you have to submit. Between those two plans, you probably have around 85 to 90% overlap with your flare management plan. They're not giving up on combining everything into one plan. They still all want their separate plans. Some of the things that, at least I find kind of, it adds confusion is, in NSPS-JA, you have a baseline. Well, then in the consent decrees, you have a base load, and these things are not the same. So I mean, now you're having to keep up with multiple things for different reasons. Everything's similar, but slightly different. And and having these conversations, especially when it's people who aren't living this day to day, is those words get interchanged back and forth, and next thing you know, everybody in the room is confused about what the person's talking about. So it becomes a time when the words are important, and keeping everybody focused is important. With the new proposed changes to MAC-CC, we're starting to see a lot of those incorporation of some of those concepts that were in consent decrees, especially with the net heating value and the lower flammability limit. But with the earlier consent decrees, we had that net heating zone or net heating value and the combustion zone limit that was going away. So now there was a number to shoot for. So that's a little bit better. But so just be aware there is overlap. Especially if you're starting from scratch and you need to install your monitoring, this is where you need to look at what are your options to maybe comply with both with one set of monitoring instead of having a set of analyzers for JA and then have another set of analyzers for MAC-CC or a potential consent decree. So there are some good overlaps in equipment, and there can be some significant savings if you can limit that amount of monitoring you have to do. So just here, just kind of shows that, pretty much everybody has the requiring for monitoring. The consent decrees, at least on the refining side, that you're going to get a total flare gas flaring limit. JA doesn't have a hard limit, but it's above your baseline, and that's just a threshold to do some more things. MAC-CC did not give any sort of flow limit. Composition monitoring, the consent decrees, you're into H2S, organic, inerts. NSPS-JA is just the sulfur you care about, and MAC-CC is just the organics and the inerts. So I mean, you can see if the consent decree could cover all your different monitoring. Again, the consent decree and JA both had minimizations. The MAC-CC did not. And for the control, it pretty much the JA was the only one because you don't need control. You don't need to control combustion to control sulfur for JA. Okay, any questions? Awesome. Hey, do we want to go switch back to the QA and Air Liquide, or do we want to move? Where do we want to put that in? We have 15 minutes until the first break.
Would you like to take all of that, or you may have all of that? You want both of you want to wait right after? Trying to have the right conversation with the right insight. How's that? You didn't have to pay me for that.
I was going to say, that is too loud. How do I turn it down?
Oh, there was another mic there or something? Anyhow, I don't want to be too loud. I have a use to never using a microphone. Yeah, good, because I over-project sometimes, so try not to do that. Thanks for letting us visit with you guys today, because we learn a lot from y'all in these visits all the time. Everything at Air Liquide starts with safety, and so we'll just make a safety point rather quick this morning. One of our most common questions we have when we're visiting with people is, what procedures are you putting in? What processes are you putting in to be safe in handling of percent level sulfurs in cylinders? Obviously, you guys are very used to dealing with hazardous chemicals, but dealing with them in cylinders where you're exchanging things, where you're moving them is not so common. And I guess probably the bottom of the barrel answer we heard in a visit a few months ago. We asked some guys, well, what are you doing to be safe? And they said, when you exchange cylinders, and they said, well, we try to stand upwind. Sorry, that's probably not as funny to everybody else, and it really wasn't funny to us, but it was kind of scary. That was about the worst that we've seen. We're not code experts. We're not trying to give code interpretations. What we are trying to say is that there's a lot of codes that apply that people aren't always aware of when they're looking at these things, and why should you be? And we've had a couple of system integrators that said, well, we didn't know that. And we're like, why would you? Why would you know that? Even the engineers, the project management people didn't know. So somebody pointed out earlier that NFPA is not a regulation, it's a set of guidelines. Do you have a set of guidelines picked out that you hang your hat on? In the event that someday there should be a problem, or you're trying to make sure that you're being as safe as you can be, you're doing the right thing, you got to hang your hat on something, right? We've had some international clients that are doing everything by IFC, International Fire Code, as far as their safety and handling. So there's more than giving answers. I think one of the secrets is to make sure you know the right questions. So are you being safe first and foremost? Do you have procedures in place so that in connecting and disconnecting and storing and using cylinders?
Message from Russell.
Russell, leave it up. Wonder how that happens when you have your volume off. But we'll just turn that off. Excuse me just a second. Do you have calibration procedures set up that are going to meet your requirements for code? And not only JA code compliant, but just your other codes and everything. I guess for most everybody, the fire marshal is the ultimate jurisdiction when it comes to safety and storage. Is that correct for most of you guys? Do you find local variations, multi-location clients? So one of the first things that really got us involved in this, what flagged us to the attention of the whole issue, is we had a couple of calls from people saying, hey, what's the highest percentage H2S that you can provide us as an EPA protocol? And we very accurately gave them the answer of 300 parts per million. And it's typical for clients to call us, say, hey, what can you do on this? What can you do on that? And then a day or two later, they call back for price and availability. And then, you get an order, you don't for a certain blend. And in this case, Russell and I were comparing notes, and we didn't get a call from anyone. And we both compared notes, and we'd had a few of these calls in the last couple of weeks, but nobody had the follow-up call. So we called the clients back, and they said, oh, yeah, we didn't need to call you because we called somebody else, and they said they make 8% EPA protocols all the time. And I don't know if you guys know, but pretty much by definition, the highest EPA protocol on a straight run is 300 parts per million. So this brought to our attention that here's another case where there's been a regulation put in place. There's not necessarily the infrastructure in place to support it. The EPA is asking you to monitor and calibrate systems at percent levels, but the highest level EPA protocol, because by definition an EPA protocol is directly traceable to a NIST reference standard, correct? Everybody's good on all of this.
Less than the reference standard
depending on the approved method. And so it's just easy enough to say 300 parts per million, right? So, but what we did is, so we've done several other cases with EPA, we started working through this and said, you've put in a regulation that the infrastructure's not in place. And so we worked with the EPA, we put forth methods. They said, that's a really good idea, we like that, only we can't take a letter from you because you're the interested party. But y'all are interested parties too, so I didn't understand this completely, but whatever, they make the rules. And so they got the letter to come through the API. API went to EPA, EPI came back to API. Interestingly enough, we're copied on both letters, so we're more than happy to share both letters with you if you want. But in giving an answer, again, they kind of raised some questions because he said, that it should be a certified standard. Well, that throws open a lot of points of what's meant by certified. And basically, just to give you a real quick note on blends, you can certify a blend gravimetrically based on the weight of it, traceableness standards. You can trace it analytically back to a reference standard or a dilute reference standard. An EPA protocol requires a certified on a reactive standard that you make the standard. You wait at least, I think it's 4 days. Don't nail me down on exact days, but you wait at least 4, you do an analysis. Then you wait at least, I think, 7 more. You do another analysis, and the 2 analyses have to line up with each other. You can get into a case where you're very precise but not accurate because they're not required to line up with the weight that you thought you put in the cylinder. Make it very simple. You could put 100 parts per million in a cylinder. You could do a first analysis at 90, second analysis at 89. The 2 analyses line up with each other, so you can certify the bottle at the average or some point around there. But just because your analyzer is consistently inaccurate doesn't mean that you necessarily have a good standard, right? And cylinders are very reactive, so there's some other things that come into life with them. But the suggestion and the development and what was done here is to create a primary reference standard so that you put your weight in, you certify it by weight, you analyze it, and the analysis and the weight have to line up within the statistical accuracy of the 2. That's what at least we refer to as a primary reference class standard. And it also allows you, along with some conditioning factors of vessels, to have extended shelf lives because of the accuracy there. At least one company goes up to 3 years. I'm sorry, sir?
Calibration gas, does it matter what, what's the advantage of doing both? If you know the actual content, the actual concentration for calibration and you're off 5% from your gravimetric, as long as the 2 analyses agree, why does it matter that the gravimetric is off? Because you've got 2 analyses showing it's 90 rather than 100, than the 100 you thought you put in, but if it's really 90 from a calibration standpoint.
Which is right. Weight is more accurate by definition than analysis. There's more variables in an analysis for inaccuracy, so which is right, but you're going to certify it by the one that has the most inaccuracy factors built into it.
The analysis was more accurate, and I'm surprised to learn the weight is more accurate.
Yeah.
So that's a very, it's a very interesting statement because that's accurate to a degree, except for the fact that you've got more variables in the analysis. Sorry to interrupt me. You've got more variables in the analysis. You got the uncertainty of your reference standard. You got the uncertainty of repeatability of your and you've got more through some squared ball that weight. You have essentially 1. Assuming you have no reactivity,
right,
which H2S does have.
I'm sorry, ma'am.
Usually by weight, if you have calibration solutions, for example, just weight.
Well, for solutions, I can understand. I thought for gases, the analysis would be more accurate.
Definitely not.
Okay.
It's just something to be there. But the combination of the 2, when they line right up with each other, that's the greatest opportunity you have for both precision and accuracy. It is a suggested thing to consider. And it's not, I won't say it's widely available, but there are certain premier companies that do things like that, at least one. But and then we've also had some people, because your calibration ranges that you're required to do on your dailies, Because you can calibrate your daily at 0 to 20%, we were surprised to see this because we don't see it in a lot of instruments, but there's some people that are actually using a zero gas on their GC. If you are going to do that, which most manufacturers suggest against doing it because you don't know if 0 means you're not getting a response, you don't know if 0 was actually a negative number, but the furthest it'll read is 0. You don't really know what 0 means, but if you do, are you using a certified zero gas? Because usually by definition with EPA,
I've run out of battery.
that's great. Yes, I got it. Thanks for seeing that, though. I'm actually not out of battery. I'm pretty charged up. It's a good week, so. But dang computer's gone. And then other questions to just ask is to look at shelf life because it can vary. There's no, especially once you get out of the area EPA protocols, EPA allows gases to be certified up to a certain period of time. It does not mean that all manufacturers certify them for that period of time. In a given class, they may only allow up to 1 year, 3 years, 8 years. You can find standards that are certified at all levels for up to 3 years. A consideration to look at when you're doing gases, and this is one of the biggest ones that we've run into, is everybody familiar with vapor pressure restrictions on calibration standards? Because I don't want to explain it if you're not. Is anybody not familiar? Basically, the way I look at vapor pressure to simplify it is that it's a propensity of a solution to want to be in liquid versus gas form. So when you increase the pressure too much and lower the temperature, then it wants to fall out and be a liquid. And so you're trying to keep this as a gas that you're running to your analyzer for calibration. So in order to keep it in a gaseous state, you have to go through the vapor pressure calculations, and we use 32 degrees or 40 degrees depending on the gas and the composition as a measuring point. But for instance, in this case, if somebody's requesting, what is this, a 1% standard for H2S, we'd run it through all the calculations. We're putting it in a cylinder that's 2,000 PSI. It's okay to 14, so it's not vapor pressure restricted. This is chart information. Well, you've already got it shared, but we can go through more with anybody that's interested. But when you go over 8% on H2S at 32 degrees, you start finding your vapor pressure restricted. And when you start getting to 20% and 30%, you become very vapor pressure restricted. Instead of having 140 feet of gas in a cylinder, you start dropping down to a third or a fifth of that level. And you get to the point that the pressure's so low at the vapor pressure restriction that you really might have enough gas to run a few dailies. And you start running into trouble, just depending on how your equipment's running and what your minimum pressure to your analyzer is. Here we're talking in the range of 30 or 50%, 500 PSI or 300 PSI cylinder. And we had clients that asked us, well, calculate that at -10 because it could get really cold. And then this is what gives you the information that says, hey, we should probably put those cylinders in a blanket. Because there's lots and lots of research on hydrocarbons. If they do drop out of solution, it gets too cold, it drops out of solution, forms liquid. You can take a hydrocarbon standard, warm it up for, 48, 72 hours, rotate it, and it'll come back completely into solution. It'll just, homogenize back, everything's great. There is no research on H2S to that degree, on what it'll do. And we've done probably more research on H2S than anybody, but it's just not possible to get conclusive information yet on that. So it's something to consider. Another question, and we're right at the 10 mark, so if y'all want to keep going, we can go or we can come back. I'll let Troy mediate on that. But I will bring on the point that some people that are having to do their daily cals at 50% above are considering using 100% H2S. It sounded outlandish a year or so ago, and it's sounding to make more and more sense all the time now, because a small bottle of liquid H2S can last you 3 years for your daily cals. So now you're not exchanging, moving it, carting it in, carting it out. You're really minimizing the handling on it. You're minimizing the overall cost of operations. There's some reasons why it's actually safer, because it's only 252 PSI at 70 degrees. So your dispersion model has some variances. So anyhow, some things to consider. You want a break and we can come back to the other considerations?